Today we are going to solve May June 2023 paper. Variant 2 code is 9709. In our first question, it says solve the inequality 5x minus c modulus is less than 2, 3x minus 7 modulus. So first of all, we should know that x modulus is always equals to square root of x square. So do the same thing with this modulus question. 5x minus 3 modulus is less than 2 modulus 3x minus 7 modulus. So I can write 5x minus 3 square root and the square of the bracket is less than 2 3x minus 7 whole square under the root. Now solve it, square both sides to remove the square roots. So it will become 5x minus 3 whole square is less than 4 3x minus 7 whole square. So open these brackets and multiply 4 with the bracket next to it. Now collect the like terms, solve them. So it will become x minus 11, 11x minus 17 greater than 0. So x equals 11 and x equals 17 over 11. How to write this? Because our inequality sign has been changed to greater than, so our answer should be like this: x is less than the small value and x is greater than the bigger value. So you have to remember this: if ax square plus bx plus c is less than 0, our answer should be written as this: x should be in the middle and x should be greater than small value and less than the bigger value. And if ax square plus bx plus c is greater than 0, so our answer should be x is less than or x is greater than, and the smaller value with the less than and greater value with the greater sign. So this is how we will solve this first question. It was not very difficult. Question number 2, solve the equation ln 2x square minus c equals to ln x minus ln 2. And he says give your answer in exact form. Okay, so I write the question. And now 2 ln x minus ln 2, 2 will become the power of x and it becomes ln x square minus ln 2. And ln a minus ln b is always equal to ln a divided by b. When two ln's are, there is a subtract sign between them, so we have to divide. So ln 2x square minus 3x equals ln x square over 2. So ln will be cancelled out. So you are left with 2x square minus c equals x square over 2. Now solve it for x. So your x values are plus minus 2 square root. So we take the positive value because the negative value logarithm cannot take the negative value. So x equals root 2, and this is in the exact form. Question number 3, on an Argand diagram, sketch the locus of points representing complex number z satisfying z plus 3 minus 2y modulus is equal to 2. So I can write z minus 3 plus 2y modulus is equal to 2. Why I'm writing this? Because the general form says z minus bracket x plus iy modulus is equal to r. So center is negative 3 and y coordinates are 2 So I can make the diagram. So this is my -3 and 2, and I can draw a circle on it. So in B part, find the least value of Z modulus for points on this locus, giving your answer in the exact form. So for this, this is my actually the line from the center of the circle which touches the origin, and my least value would be after that radius to the origin. Let me draw it with black line. So this is my least value. So how can I find this? I can take the whole right angle triangle and I will solve it. So look, this is my 2 is my radius, -3 is my distance from origin. So 3 square plus 2 square whole under the root equal √13. So you subtract least value of Z modulus would be subtract 2 from √13 and leave it here. And so this would be our answer. Question number 4, solve the equation 2 cos of x minus cos of x is equals 1, and the range is x is less than equal to 2 pi greater than equal to 0. So cos of 2x equals 2 cos square x minus 1. This statement came from the formula cos of 2a equals 2 cos square a minus 1. So therefore cos of x would be equal to 2 cos square x by 2. We divide 2x by 2, right? So cos of 2a is equal to, now the equation becomes 2 bracket 2 cos square x over 2 minus 1 minus cos half of x is equal to 1. So 4 cos square x over 2 minus cos of x over 2 minus 3 is equal to 0. So cos of x over 2 minus 1, 4 cos of x over 2 plus 3 is equal to 0. So actually I solved it like a quadratic equation and I factorize it. So in blue, let me explain you this. Let cos of x over 2 is equal to u. So our equation will become 4u square minus u minus 3 equals 0. So 4 3 is 12. Make the factor of 12 so that we can use them to bring the minus 1 value. So minus 4 plus 3 brings the minus 1 value. So use minus 4 and plus 3 in the middle. So this is called midterm breaking. So 4u square minus 4u plus 3u minus 3 equals 0. So from the first two expression, 4u common, so u minus 1 and plus 3 common. So u minus 1 equals 0. So 4 plus 3 and u minus 1. Now write back cos of x in place of u. So 4 cos of x over 2 plus 3 and cos of x over 2 minus 1 equals 0. That's how the red working was done. Now cos of x over 2 is equal to 1 and cos of x over 2 is equal to minus 3 over 4. So where cos of x is equal to 1, let me show you on the diagram. So pi by 2 pi, 3 pi by 2. So this is my and 2 pi. So at 0 cos is 1, at pi by 2 cos is 0, and at pi cos is negative 1. At 3 pi by 2 cos is 0, and at 2 pi our cos of x is 1. So we will take this value, I'm circling it with red circle, and I have one more 0 at 2 pi, but I'm not going to take this value because our range is now different. Look, x is less than equal to 2 pi and greater than 0. So actually our x is half. So multiply it by half. So multiply half on either sides. So you will get the new range. Half x is less than equal to pi and greater than equal to 0. So our 2 pi has gone. So we have to look till pi. So we have only one value before the pi. So that's why we will take just one value from it. Now solve x over 2 is equal to cos inverse of 3 over 4. And this is actually 0.7227. This is our basic angle. And cos is negative in the second and the third quadrant. So I will pick the second quadrant. So I will subtract 0.7227 from pi. So that is 2.4189. And now I will solve this value with x over 2. So x is equal to 4.84. The negative value I will not consider because the range is from 0 to pi. So our two answers are one is 0 and other is 4.84. Question number 5. The complex number 2 plus yi is denoted by a where y is a real number and y is less than 0. It is given that f of a is equal to a power 3 minus a square minus 2a. Find a simplified expression for f of a in terms of y. So f of a equals a cube minus a square minus 2a. So our a is actually 2 plus yi. So I will write 2 plus yi wherever I see a. So 2 plus yi power 3 minus 2 plus yi power 2 minus 2 into 2 plus yi. So 2 plus yi power 3. So this is a formula. Let me write it on the side. A plus b power 3. This is equals to a cube plus 3a square b plus 3ab square plus b power 3. So apply this on the first bracket. So this is 2 power 3 plus 3 times 2 power 2 times yi plus 3 times 2 times yi power 2 plus yi power 2. Sorry, yi power 3. Now minus, the second bracket is simply a plus b whole square. So you 4 plus 4 yi plus yi whole square. And the last one is you multiply 2 inside its bracket, so it becomes 4 minus 2yi. Now simplify this whole thing. So it will become 8 plus 12yi plus 6y square I minus y cube plus y cube I power 3 minus 4 minus 4yi plus yi square minus 2yi. Actually, I simplified the like terms. So 6yi minus 6y square minus y cube I plus y square. So this becomes minus 5y squared plus 6y plus 6y minus y cube I. So this part is the real part, minus 5y squared. In B part, given that RA f of A equals minus 25, the argument of A. So real part was minus 5y squared, so equate it with minus 20. So from here, y square equals 20 over 5, y square is equal to 4 and y is equal to plus minus 2. So y is less than 0, he told us in the question. So pick y is equal to negative 2. Now argument, so a is equal to 2 plus yi. So a is equal to 2 minus 2i. So this would be, in place of y I am writing negative 2. So your diagram looks like this, 2 negative 2. So this is your 2 negative 2 and your theta is here. So theta is equal to y over x means negative 2 over 2, which is negative 1. So tan inverse of negative 1 is, tan inverse of 1 is actually 45 in degrees and pi by 4 in radians. So put the negative sign with pi by 4. Question number 6, equation cot half x equals 3x has one root in the interval 0 to pi denoted by alpha. Show by calculation alpha lies between 0.5 and 1. So write this equation as f of x, cot half x minus 3x, bring 3x towards cot of half x. So now put the value like f of 0.5 and solve it. You will find 2.42, which is greater than 0. And now place f of 1 and solve it with the help of calculator. So you find negative 1.17, so this is less than 0. You can write there is a sign change, hence alpha lies between 0.5 and 1. B part, show that if a sequence of positive values given by the iterative formula this converges, then it converges to alpha. So first of all, you ignore all the subscripts and write it without subscript. Now what would be our first value? So you multiply it by 3. So 3x equals x plus 4 tan inverse of 1 over 3x. So bring x towards 3x, so it becomes 2x equals 4 tan inverse of 1 over 3x. Now divide it by 4, so you get 2. X over 2 equals tan inverse of 1 over 3x. So tan of x over 2 is equal to 1 over 3x. Now 3x goes there, cross multiply. So 3x would be equal to 1 over tan x over 2. So 1 over tan is cot actually. So 3x is equal to cot of half x. Use this iterative formula to calculate alpha correct to 2 dp. Give the result of each iteration to 4 decimal places. So x is equal to, write down this equation, and my value alpha is less than 1, greater than 0.5, so you can take any value between this range. So I took the mid value. My first x is the mid value, which is 0.75, so I write x naught equals 0.75. So my x1 would be, I will place 0.75 in x in the equation, and my value is 0.8076. Remember, you have to write up to 4 decimal places. Now use this result in x2. Wherever you see x, you put this value and calculate it. The value is 0.7911. Now use this in x3. 0.7954. Now use this again in x4. 0.7945. Now use this in x5. So 0.7945. So check for one more value. So now you can check up to 2 decimal places, your result are the same. So this would be your final answer. So you can write alpha is equal to 0.79, 2 decimal places. Question number 7, the equation of a curve is 3x square plus 4xy plus 3y square equals 5. Show that dy by dx is equal to minus 3x plus 2y over 2x plus 3. This is implicit function. So dy by dx is equal to the differentiation of 3x squared is 6x plus, and differentiation of 4xy is, you take 4 outside, and x and y are two functions, so x is my first function and y is my second. So I will use product rule. First function as it is into derivative of second means dy by dx of y, which is 1, plus second function as it is, my second function is y, into derivative of first, my first function is x, so derivative of x is 1, plus differentiation of 3y square is 6y. But whenever you differentiate the y variable, always write dy by dx with it. And the differentiation of 5 is 0. Now 6x plus, multiply 4 with the bracket, and now collect the dy by dx terms. Now take dy by dx common and send 6x and 4x on the other side of is equal to sign. Now isolate dy by dx, divide minus 6x minus 4y by 4x plus 6y. Take minus 2 common from the numerator and 2 common in the denominator. So 2 to cancel. So your final answer is minus 3x plus 2y over 2x plus 3y. And you can write shown. B part, hence find the exact coordinates of the 2 points on the curve at which the tangent is parallel to y plus 2x. Tangent is parallel to this, so this means y is equal to minus 2x, so your gradient is negative 2. It means your gradient m of tangent is negative 2. So dy by dx is minus 3x plus 2y over 2x plus 3y. So I can write this is equal to minus 2. Minus minus cancel. So you multiply the denominator with 2 and straight up the equation. Your x is minus 4y. Put this value in the main equation. So your y is plus minus 1 over root 7, and your x is equal to minus 4x plus minus 1 over root 7, and coordinates are, when x is minus 4 over root 7, your y is 1 over root 7, and when your x is 4 over root 7, your y is minus 1 over root 7. The variables x and y satisfy the differential equation. This it is given that y equals 0 when x is equal to 1. Solve the differential equation, obtaining an expression for y in terms of x. So this is your dy by dx. Separate the variables. So it becomes 1 over 4 plus 9y square is equal to 1 over e power 2x plus 1 dx. Now integrate both sides. So integration of 1 over 4 plus 9y square is actually 1 over a square plus x square. Our a square is 4 here, and you can say 2 square. And our x square is our 9y square. So it opens like 1 over a, tan inverse of x over a plus c. So you can write integral of 1 over 9 over 4 over 9 plus y square dy. So this becomes 1 over 9 integral 1 over 2 whole power 3 plus y square dy. So 1 over 9 into 1 over 2 over 3 tan inverse of y over 2 over 3 plus c. You can compare it with the journal form which I have written just above it, 1 over a tan inverse of x over a plus c. So simplify this. This becomes 1 over 6 tan inverse of 3y over 2 plus c. So finally 1 over 6 tan inverse of 3y over 2 is equal to, now the second part, integral of 1 over e power 2x plus 1. So bring that denominator in the numerator. So integral of this is, you have to write e power minus 2x minus 1 as it is, then differentiation of minus 2x is minus 2 and you divide it by that, plus k. So 1 over 6 tan inverse of 3y over 2 equals negative 1 over 2 e power 2x plus 1 plus k. Y equals 0 when x is equal to 1. So put 0 in y and 1 in x. So tan 0 is 0. So your k is 1 over 2 e power 3. So 1 over 6 tan inverse of 3 over y over 2 equals minus 1 over 2e power 2x plus 1 plus 1 over 2e power 3. So tan inverse of 3 over y over 2 equals, now 6 will multiply on the other side, 1 over 2 e power 3 minus 1 over 2 e power 2x plus 1. So tan inverse of 3 over y over 2 equals 6. You can take 1 over 2 common. So it becomes 1 over e power 3 minus 1 over e power 2x plus 1. So 2 will cancel 6 by 3. Tan inverse of 3y over 2 equals 3 over e power 3 minus 3 over e power 2x plus 1. So 3y over 2 is equal to, now tan inverse will become tan bracket 3 over e power 3 minus 3 over e power 2x. Now y equals 2 over 3 tan 3 over e power 3 minus 3 over e power 2x plus 1. In the b part, he says state what happens to the value of y as x tends to infinity. Give your answer in the exact form. So as x approaches to infinity, so 3 over e power 2x plus 1 approaches to 0, because we know that 1 over 0 is equal to infinity, therefore 1 over infinity is equal to 0. So y is equal to 2 over 3 tan of 2 over e power 3 will be left, because the next portion will approach to 0. Number 9, let this equation f of x expressed in partial fraction. So this is a repeated form. 2 minus x whole square means it's a repeated form. So 2x square plus 17x minus 17 over 1 plus 2x times 2 minus x square. We can write it as a over the first fraction plus b over 2 minus x and c over 2 minus x whole square. This is the way we write it if we see the repeated form. So now take the LCM. And the denominator on either side of is equal to sign will be gone. So only write down the numerators. And now let 2 minus x is equal to 0, because we have to make at least one from a, b and c. We have to make one of them 0. So the bracket multiplying by a, 2 minus x equated with 0. So from here you get x is equal to 2. By writing x is equal to 2, your whole a would become 0. Wherever you will see 2 minus x, that bracket will become 0 and it will make all the values zeros. So let us write x equals to, so now b becomes 0, a becomes 0, and the first expression, if you solve it, it gives you 25, and then 25 is equal to 5c, and from here your c value is 5. Now try to make b 0 by writing 1 plus 2x is equal to 0. Let 1 plus 2x equal 0. From here x is equal to minus 1 over 2. Now write down minus 1 over 2 everywhere you see the x. Okay, these values are gone. The left side is minus 25 and the right side 25 over 4a, and from here your a is equal to minus 4. Now to calculate b, we don't have any value to equate of x to equate with 0, so you can take any value, whatever you like. So start with the smallest values. So let x be any other number, so I'm taking x equals 0. Write down zeros in x. Now solve it. So minus 17 equals 4a plus 2b plus c. Now write down the value of a and c. And from here you can calculate b. So b is equal to minus 3. Now you have all the three values with you, A, B and C. Now shape it up. So minus 4 over 1 plus 2x minus 3 over 2 minus x plus 5 over 2 minus x whole square. B part. Hence show that from 0 to 1 f of x dx is equal to 5 over 2 minus ln 72. So limit from 0 to 1. F of x is my partial fractions. And differentiation of 1 plus 2x is 2. But in the numerator we have 4. So you multiply and divide it by 4, so you get minus 2. So now you can write minus 2 ln 1 plus 2x plus the second would be take out 3 outside. So you can write, because the differentiation of 2 minus x is minus 1, so that minus 1 you multiply it in the numerator, it makes positive with the already negative sign there. So you can now write 3 ln 2 minus x modulus plus, now separately I'm showing you 5 over 2 minus x whole square, how to integrate it. Bring that 2 minus x whole square in the numerator, the power would become negative. So you add 1 in it and subtract. So it becomes 5 over 2 minus x. Now put the limits from 0 to 1. Now upper limit minus lower limit. 1 in x everywhere you see x minus lower limit zeros. Now simplify minus 2 ln 3 plus ln 5 minus 2 ln 1 plus 3 ln 2 plus 5. So ln 1 is always 0. So these are zeros, I cancel them out. So minus 2 ln 3 plus 5 minus 3 ln 2 minus 5 over 2. So 5 minus 5 over 2 minus 3 ln 3. Minus 2 ln 3 means 2 will become the power of 3. So it becomes minus ln 3 power 2 plus ln 2 power 3. So 5 minus 5 over 2 is 5 over 2 minus ln 9 plus ln 8. 5 over 2 minus, logs are added, so they multiply. So I can write ln 9 into 8. So 5 over 2 minus ln 72, which is shown. Question number 10. Find the exact coordinate of M. So at maximum point, our dy by dx is always equal to 0. So first function and second function, the product rule I'm going to apply. So first function as it is into derivative of second plus second function as it is into derivative of first. These 2's are gone. So minus x over 5 over 3 minus 2, 2x under the root. So write down the positive value first and the negative value ahead of it, so that there should be no difficulty in taking LCM. So your x is equal to minus 2 over 3. So now put this in the main equation to get the y value. So your y is 13 by 3 times 3 plus 4 over 3 under the root. Thirteen over 3 whole under root means under root 13 over 3 under root 3. So under root 13 over under root 3 multiply under root 3 over under root 3. I am rationalizing the denominator. So it is 39 over root over 3. So 13 over 3 times 39 over 3. So this is my y coordinate. This is our final answer. Using the substitution, u is equal to 3 minus 12, find the integration, the area of the shaded region bounded by the curve and the x-axis. Give your answer in the form a root 13 where a is a rational number. So y is equal to this, and x plus 5, 3 minus 2x root is equal to 0. Y it is equal to 0 because at x-axis the y coordinates are 0. So I got two factors. X plus 5 equals 0 and 3 minus 2x is square root is equal to 0. So one x is equal to 5 and other x is equal to 3 by 2. Now integration from minus 5 to 3 by 2 and this equation dx. I have told to use u as a substitution. So my u is equal to 3 minus 2x. From here differentiated du over dx is equal to minus 2 and make dx the subject. So dx would be equals to minus 1 over 2 du. Now from here my x is equal to 3 minus u by 2. Change the limits. When x is equal to minus 5, u is equal to 3 minus 2 times minus 5. So u is equal to 13. When x is equal to 3 by 2, put this 3 by 2 in, u minus 3, u is equal to 3 minus 2 times x. So my u is equal to 0. So now you write down the new limits. 13 comes the lower limit and 0 comes the upper limit. And x plus 5 would be written as 3 minus u over 2 plus 5 because my value of x is 3 minus u over 2. And 3 minus 2x under root would become u under root. Minus dx would become minus 1 over 2 du. So take 1 over 2 outside. First simplify this. So it becomes 13 minus u under root u du. So now you are multiplying under root u with the bracket. So now it is easy to integrate 13u power 3 by 2 over 3 by 2 minus u power 5 by 2 over 5 by 2, limits from 13 to 0. Now 26 over 3 u power 3 by 2 minus 2 over 5 u power 5 by 2, 13 to 0. Now 26 over 3 upper limit minus lower limit. This first bracket becomes 0, so minus 1 over 4 times this is minus 26 over 3, 13 times root 13. Actually, I can write 13 power 3 over 2 as 13 power 1 into 13 power 1 over 2, and 1 over 2 means under root, so I can write 13 power 3 over 2 as 13 times root 13, because I have to bring this shape, so I have to be careful. So 2 over 5 and 13 square root 13. So 13 power 5 by 2 is actually, I can write 13 power 2 into 13 power 1 by 2. So I'm using the indices rule. When you 13 power 2 multiply 13 power 1 over 2, bases are same and their multiplying power must be added, so power becomes 5 by 2. So that it becomes 13 power 2 root 13. Now, minus 1 by 4 multiplied by this, it becomes 169 over 6. Simplify this, you will get 169 over 15 root 13. So this is your answer. Question number 11. Points A and B have position vector this and this respectively. Line L has equation this. Show that line does not intersect the line passing through A and B. So the vector OA is 1, 2, minus 2. I'm using the column vector. You see the position vector of A is I plus 2j minus 2k. So I means 1, 2j means 2, and minus 2k means minus 2. So I wrote the coefficients of I, j and k in the column vector. And because it is a position vector, so that I wrote OA and B as OB. And I wrote the coefficient of I, j and k of 2i minus j plus k as 2 minus 1 and 1. So my general form of vector equation I equals a plus lambda times b. So my A is 1 minus 1, 3. It is from the value I took it from the line L has the equation R equals I minus j plus 3k. So I minus j plus 3k means 1 minus 1 plus 3. So I wrote it R equals, this is my A value, plus mu times 2y minus cj plus 4k. I'm writing it as a column vector. So this is line L. Now AB means OB minus OA. So I found the column vector of AB as 1 minus C3. This is actually the direction vector for line AB. OA plus lambda times AB. So OA is 1, 2, minus 2 plus lambda times AB. I just found out 1 minus C3. So equate the equation of L and equation of AB. So L equals AB. So I components are 1 plus 2 mu of line L is equal to, and J components are minus 1 minus 3 mu. K components are 3 plus 4 mu. Now write down the same thing with the AB. So 1 plus lambda, 2 minus C lambda, minus 2 plus 3 lambda. Now mark them equation 1, 2 and 3. So use equation 2 and 3 and try to solve mu and lambda. So minus 1 minus C mu is equal to 2 minus 3 lambda. So from here I'm actually isolating lambda, which is 3 plus 3 mu over 3. Put this value of lambda in equation 3. So you will get mu equals minus 2. So put this mu in equation 2. So you get lambda equals negative 1. So number 1 plus 2 mu, and this is minus 3, and in AB 1 plus lambda 1 plus minus 1, so this is 0. So they are not same. So L does not intersect. Find the position vector of the foot of the perpendicular from A to L. So okay, this is the condition. Line L, and I wrote P here. So P lies on L. So OP is equal to 1 plus 2 mu. Same direction vector as we know, 2 minus 3 and 4. So 1 plus 2 mu minus 1 minus 3 mu plus 3 plus 4 mu. So AP equals OP minus OA. So OP is my 1 plus 2 mu minus 1 minus 3 mu, 3 plus 4 mu, minus OA I have already. So this is OA. So this is equal to 2 mu minus 3 minus 3 mu and 5 plus 4 mu. This is my AP. So because they are perpendicular each other, so AP dot P would be equals to 0. Dot means multiply. So 2 mu times 2 plus minus 3 mu times minus 3 plus 5 plus 4 mu times 4 equals 0. Now simplify this. Your mu is negative 1. So put this value, negative 1 here. So minus 1, 2, minus 1. So this is the position vector of foot of the perpendicular from A to L. And you can write in IJK form. So you can write minus A plus 2J minus K. Thank you, Vacho. This is my number.